Hello everyone, welcome to the session. We will cover in bubble chart, some interpolation, basics and stuff. I will break down the performance before starting, so that others also can join with them.
आवाज क्लियर नहीं आ रही आपकी।
Okay, are we clear here? Is
हाँ
it
सर,
clear
अभी
now?
क्लियर है।
Oh,
हाँ क्लियर है अब।
okay, thanks. Okay, let me get started then. So at first we'll discuss about bubble shot and pointer. Bubble shot is something we covered slightly in the last week, uh, but still we'll go through that once again. And also we'll go through pointer, then we have some bisection method and neutral elapsing method. Then after that, we'll go through some MCQ and some numerical problems. So what exactly is bubble shot? It is basically, if I show you an example, suppose we have an array 50, 6, 12, 7. So these are the four elements of an array. So in bubble sort, what we do is that we compare one element to the element on each side. So for example, 50, 6, we'll compare 50, like 50 and 6 if they are if the first number is greater, then we'll just extend the position. So 50, 6 will become 610. Next step, 50 and 12 again. 12, 50 is greater than 12. So it will again change the place. So 10, 50. Uh, sorry, 12, 50. Then again we'll compare 50 and 7. Since 50 is the largest, so 50 will come here, 7 will come here. So after one pass, what is happening? 6, 12, 7, 50. So remember, like one thing you note here is that 50 was at the beginning, at the 50 was at the first position. At the end, since this is the highest number, it change the place again and again. Ultimately, it came to the last position. But all the other positions, let's say 6, 12, 7, they are not really sorted, right? So this is the bubble chart. So at each pass, at first pass, we will only go to the last position. If you look at the last position after the first pass, you will see the highest number. So in the next pass, what will happen? We will come here. In the next pass, 7 will come here. And finally, 6 will come here, like this. So this is a very basic bubble chart. And this is nothing, basically just you run through all the examples from my outer loop. You run another you run another loop, another inner loop, and you just swap all the elements which is like greater than the like elements which is in the previous steps. So it is basically in the same example, let's say I am considering something like this, initially I have 50, 6, 12, 7. After first pass, 50 will come at the end. Then after second pass, second highest, which is second highest among this second highest is 12. So second highest element will come at the second last. After third pass, third largest element, which is 7, will come at the third position from the last, like this. And at this point, obviously, only remaining element is 6. So it will be here only after pass 3. Okay. So how to write the algorithm? And just like I said, this is like just an algorithm. No, this is not a C code. So this is basically, suppose we have an array and we have a size n. Size n means like number of elements in the array. So we run a loop from n minus 1 to 1. So from like this position, this is the last index. So if the array size is n, last index is n minus 1, right? So we go to from this position to this position, we run a loop. Sorry, this position to 1, we run a loop and we compare with the previous one, like this. And j equal to 0 to j minus j less than I. So we run a loop, which is from this side, we run a loop, and from this side to, like, let's say initially the n is 4 here. So we run a loop from 3 to 1 and another loop from 1 to 3, like this. So then we, how do? We check if the element array of j, which is the inner loop, if it is greater than the next element. So basically what I'm saying here is that array j is initially 0. So here I will compare 0 with 1. If this is greater, then just fine. If this is greater, then we'll change the value. Then the next element will be j equal to 1. So in that case, we'll compare this and so on. It will continue like this. So ultimately, what will happen? Like heavier element, in a larger element, it will go to the right side here, like this, so on. So this is what we call bubble sort. Then this is a very basic C code of this, like similar to the pseudocode only. Just for I equal to n minus 1, we'll start from the last element and we'll go to the we'll iterate through this element, right? And this is the outer loop, and inner loop will go from this to last, like the outer loop. So maybe I can show you with an example, like bubble shot. There are some very interesting visualizations. Let me show the visualizations. So from examinations point of view, there can be questions like you may give an array and you may be asked that what is the what will be the state of the array after one iteration. So in that case, one iteration, so it is quite easy actually. Like you can totally say that even without running all the swapping operation and everything, if there is an option where 50 is the like 50 is the at the end, so you can blindly say that this is the right answer. Like this is the state of the array after one iteration. So let me show the swapping. I will start this here. Let me. Okay, let me like so. This is suppose the array, and I want to sort the array. So notice one thing. So it will compare one element with the next element. So initially, what will you compare? 31 and 49. So 31 and 49. Oh, let me slow it down a little bit. So 31 and 49 will compare. It is like 49 is higher, so just fine. No changes will occur. Then 8 and 14. So now 49 is higher. So ultimately 49 will go to second position and 8 will come to the first position. And by first and second, I mean the array index, not the like actual, like not that, not this is like the first element. This is like index element at the index one. So this will change place. Now again, we'll compare it to 2 and 3. So again, 49 is higher. So it will come here. Then again, 49 it will go there. 49, 49 is same. So it will not change place. Similarly, this 49 will go there. Like this. And ultimately at the end, sorry, at the end, at the end, you can see that the largest element went to the last position. So this is, if you just remember this, remember the algorithm, you can say that like if you are given a large array and you are asked that what will be the output, or like what will be the array after the first pass, you don't really need to consider all the sorting which will like take place. You can just blindly answer that 49 9 is the highest number. So if there is an option that 49 is the last position, we can blindly say that that is the right option. Then similarly, if we ask what will be the correct option after like what will be the state of the array after third iteration. So what will be the answer in this case? Like last two days and last two numbers will be 49, 49, and third will be 42. Right? So like this. So ultimately, this iteration will continue, and at every point, we'll get a highest number there. At every point, we'll get a highest among the remaining array coming at the end, like this. Similarly, here 36 will come at the end. Next 34, 31. Now it will come. Then it will go here, and now there is like this. So okay. So one thing to note here is that there can be multiple ways to implement double shot. So one thing is that let me just copy the code once. So actually, bubble shot is one of the easiest sorting algorithm to implement because you don't have to check anything. You just have to run two loops and within that one single operation. Like there is no if else, like only one if that if it is greater than less than. That's it actually. So let's say I have an array like this. I am passing an array and n and sorry. Let's say I have also another function that swap, right? Is WAP. Okay, assume that we are not passing address. Okay, just for a minute, assume that we are doing pass by value int a, int b, and stop means what? We have to take an temporary variable a equal to b, b equal to 10. Right. So this is the sorting algorithm. And simple sorting. So let's assume that we are not doing pass by address, and let's say we have an array in x is equal to maybe 7, just I'm giving some value. So this is the array, and int n is equal to 1, 2, 3, 4, 5, 6. So let's say I am calling the sorting function, the double sort. I'm giving the array, which is x, and giving the number, which is n. Then after that, let me print the I equal to 0, I less than n, And I am printing the value array of. So the thing here is that so the question is that will this be sorted? Uh, mm, mm, Sorry. Syntax issues. This is X. All right. So see one thing here. The logic is quite correct, not totally correct, it is quite correct. So basically what I'm doing here is that I am starting from end of the array. I am doing the inner pass from 0 to the j, and I'm swapping if the elements are if array of j is greater than array of next element. So I'm swapping. But the issue here is that no, here I am passing xj. All right. So xj is what so one thing to note here is that if you are passing an array, by default that is passed by value, passed by address. But if you are passing a single element x of j, so this is passed by value. So what it will do, it will just let's say array of 0, it will just copy 7 and pass the copy to here and pass the copy pass the xj plus 1. So 7 and 5 it will consider A and B and pass that here. And it will exchange the position of 7 and 5. But the issue is that the change is occurring in the copy, not in the actual array. So the array will remain the same. So any change that is occurring here, that is occurring in the copy, and this is not getting reflected to the actual thing. Let me also draw that. So assume this is the memory, and we have 6 compartments. And some other stuff like copy and other system. So let's assume that this is the array index of 0, 1, 2, 3, 4. And we have, let's say, I just need the first element. Let's say the first element is 7 and 5. 7 and 5. So when I'm calling this one, when I'm calling swap this function, so here I'm not passing I'm just passing a single element, right? I'm not passing the entire array. So the issue here is that it will copy the 7 to a new memory location. 7 maybe somewhere. So here and 5 to some other memory location, maybe here. And it will give this two, 7, 5. And whatever the swap operation is, here, this one. So this is the swap function. So what is happening here is that it will exchange this two. So here it will come to here it will be like 5, here it will be 7. So if you print within this function, if you print something here, it will show 5, 7, not 7.5. But if you print the array like anything you print outside this function, this exchange will not be reflected. So how to really fix that? There is one very simple solution. Just don't copy this. Don't make this copy. Just pass the address. So how to pass the address in C? You can just write and person sign here, person sign here. So ampersand in C is passing an address. So I'm passing this, but here what I need to change something here. Earlier I was saying this will be an integer, this will be an integer, right? But now what I am passing? I am passing address. Here also I'm passing address. So that is like we can. This is like mismatch, right? So if I compile it right now, it will throw an error. So see, like I am passing an like integer, but I'm like I told that I'm passing an I will pass an integer, but I'm passing not in something that is not integer. So what can I do? We can create a pointer type variable. Pointer is something which is like used to store address. Alright. So what I can do, I am using this. So I can do one thing. I can write star A. Star A means whatever the value is, there is in A. So what I can do is that, so if you go to the diagram, I am passing this address there, in here. Assume that there is a star here, there is another star here. So, and there is another star here. So what I'm saying is that int 10 is equal to star A. That means I want the value which is stored in the address A. So address A is this address. Address is this address. So I'm saying that in 10, I will assign 7. Okay. Here in B, here also I have to give star because see, here, right now, A and B are the address, right? So I cannot just use those. So I'm saying that in B, so here from B, I will take the 7. Sorry, from B, I'll take the 5 and assign it to the A. So A star A is equal to 7. Assuming that this is star is equal to 7 and B is equal to, sorry, star A is equal to 5. So in value of star plus 5 and B is equal to, here also star B is equal to 7. So note one thing here, since we are passing address here, whenever I want to use the value of the address, I have to give star. So here I want the value which is stored in address A, so I have to give star. Then here also I have to give star because I want to store the value of value which is present in B, and I want to store that in like, A. And similarly, star B. So I want to copy the value which is present in the 10 to an address which is in B. So like this, if we pass it like this, then it should give the correct answer. So see, like right now, after doing the call by reference, which is also called call by address. So in this case, we can get the correct output because it is actually sorting the things within. So if we do the pass by address, then actually it will, the reflect the change will get reflected here. It will become 5 and it will become 7. All right. So anytime if you have any confusion regarding what I'm saying, please unmute yourself or you can just type in the chat or discuss. So let me go to the next one. Okay, so this is the same thing only which I explained right now. Pointer also same thing only. Skipping this. Okay, and program also I have told just right now. So just first working, you have defined a function, and for bubble shot you have defined another function. Obviously, you can do everything within the main function only, but that will become flat out. So not really good idea. It is always a good idea to like break the functionalities into multiple functions. Okay, so one thing to note here is that there are some issues with arrays in C. So one thing is that let's say I am defining an array of size 10, right? And I am calling array of 11. Sorry, array of 10 only. Like, array of 10 means what? 0 to 9, right? Indices are 0 to 9. But if I ask printf array of 10, printf array of 11, so it will not show an error. It will not show that you have defined 10 elements only, but you are trying to access 11 elements. There is no like uh, checking from the compiler or else it will just like see. Mm, and see what happens. It is storing the contiguous location on a parameter. So if you allocated 6 elements for this, if you say that like this is suppose array and it 0 to 5, so array of 6, it is array of 6. Now if you say array of 7, so what will happen if you just give whatever value is there in array of like in this case. So after 5, there is 6. So it will just check that what is the value there. So what issues can occur? It can happen that there are some garbage value here. You are just using that. So because if you don't allocate it, if you don't generate whatever value it is there by written by another program, so that it will just so that thing you have to handle that manually. In many other languages, they will throw some error. This is like out of range of whatever value, like whatever the size of the array you have requested. But this checking is not done in C. You have to manually like handle that. You have to make sure that you're not giving some index which is outside of the range of the array. Okay. Another thing is that in other C like other version of C, you could not define some variable size array. So let's say here you have defined a function void func, and you are giving a size, and like suppose I have an array, I have a size like I have say let's say 100, and I want to define an array within the function with size. So size is a variable. It can be 100, it can be 1,000. So in older version of C, that is not really possible. So basically, you have to define like 100, 500 in the program itself. You cannot just like do it. Like, you cannot keep it as a variable. You have to define it before. So there was some there was a method for doing that. There was something called malloc, but the syntax of that is quite complicated. So in newer versions of C, that is not really an issue. But yeah, if you are facing some issue, so you know how to diagnose it. You should know that this is because of the compiler. The compiler is kind of following older standard, so that is why it is not accepting something like stamp of some variable, array of some variables. And another thing is that obviously you should not consider array of 1 to access the first element. So array always starts with 0. And one thing is that suppose I have n element, 100 elements. So last element is array of 99, not 100. So these are the pitfalls you need to be keep in mind. Then let me come to linear search and binary search, and then I will come to the bisection. So in linear search, what do we do is that suppose we have an array. So let me just take example of the same array only. 7, 5, 33, 21, 45, and 9. And in linear search, let me just the main element. Okay. So in linear search, what it will do is that linear search. So basically, I will go through all the elements one by one. I equal to sorry, I equal to 0. I will n plus s. I will go through all the elements one by one, and if the array of I is equal to the element. So let me just define an element as an element is equal to maybe 40. Right? So suppose I'm trying to find out uh, 45 in the array. So if x of I is equal to that element, then I know that printf found the element. And then it can say that maybe we can just build it. We don't need to find that. We don't need to check again. But the issue is that suppose how do we know that we have found the element or not? Like at the end we have to see that we have found the element or not. So maybe instead of 45 there is like 46. So let me just run this right now only. So 45 is there. Also print the index percentage d. So I am printing the index where you have found the element. So 0, 1, 2, 3, 4. For the index, we have found the element 40. But now let's say I want 46. So what will happen? Nothing. There is no else case. And if I give an else here, so if I just just let me give an example. Enter not found, let's say. So what will happen? It will just print not found again and again for each of the elements, right? For 7 it is not found, right? So this is not something we want. We can define a flag. Decide to flag, or let's say found is one. Found is equal to maybe 0. And if we actually find the element here, then we can say that found is equal to 1. So if at the end of this loop, if found is still 0, that means we have not found the element. Then we can print like this. If found is equal to 0, then printf element for the syntax. So element not found like this. So the thing is that here the arrays need not to be sorted. Here you see 5, 7, 5. This is in random order. But still, since it is written to each of the element one by one, that is not really an issue. It will search for the element and it will find the element. But the issue is that if the array size is very high, maybe 10,000, like in large databases, this is quite common. Like let's say if you are handling a social media site, you have list of all the users and stuff like that. In a large database, that is very common that you have very large number of uh, values. And you how to check that? Like suppose you want to check if some number exists or not. So how exactly, like every time if you want to those many those many comparisons, those many elements in future, this is quite time consuming. So one solution for that is binary search. So in binary search, it is basically what we have to do is that uh, here it needs to first thing is that it needs to be sorted. So assume that by some way we have sorted that like this. Maybe we use bubble sort like I explained earlier. 7, 21, 33, 44. Right. Okay, forget about this. So in binary sort, what do we need to do is that we have to find a middle position. So there are 6 elements here. So what will be the mid position? 0 plus 6 by 2, which is 3. So mid position is 0, 1. Okay, since let me just go with the first index and last index. So this is the index 0, this is the last index, which is mixed having. So what is the mid position here? 9. Like it is like 0 plus 5 is 2 and 5, but since we cannot represent to 5 given 5, it is so let me trunk it down to it. So at first we'll check if this element is like this element is equal to 45. Let me say I'm searching 45. The answer is no, and I can see that this is lesser than 45. So that means the element 45, if it exists, it will be in the right side. So right side has now 3 elements. I'll again check the mid element. This. So then I'll again check that 33 is actually lesser than 45. So 40. So I'll check here again. 45. The answer is like yes, it is matching with this element. So we can say the okay. Assume that we instead of 45 we have let's say 43. So again the same process. We'll check 9. After 9 we'll check within this 3. 33. So 43 is greater than 33. So we'll check here 45. This is again not equal to. So here I am saying that it is in the right, and here I am saying it is in the left, and there is no element in between. So you can conclude that 43 does not exist. So again, for binary search, the main advantage is that it is quite fast. So for example, if you have 1 lakh element, so in that case, so here so it is not 1 lakh, it is like 1 million sentences, so 1 million elements. So if you run a linear search, how many comparisons do you need? Like if you can do it in one comparison only, like if it is in the first element. If it is the last element, it can go to the like 1 million steps. So what is the average case? It is like 500,000. So this is quite large number. But for binary search, you can do it within 20 comparisons. So this is quite really fast. But only like one of the main issues that it has to be sorted. For binary search, you need an sorted. Okay. So then let me come to like array of strings. So basically, whenever we have property now, it is like we have an array, and within the array we have some numbers, and numbers in the sense we have mostly integers, sometimes some floating points. But let's say I want to store an array. Basically, let's assume you want to store 2 arrays. One array with marks, another array with marks. So again, like similar to the marks also, like all the array, it should be of same type. So marks here, if it is integer, all the all the elements should be integer. Similarly, for names as well, you cannot put like you cannot say like I want the third element to be like number integer. That is not possible. It should also be string. So assume that you have some array, you have the names of people, and assume that they are sorted. Okay, for a moment, let's assume they are not sorted. You want to search within the array linear like 1 by 1 to find out like if there is someone called Bud in the array. So how to do that? So basically, you can pass the array. So let's assume that array name is the array of string, you can pass the size that there are 5 elements in the array, and you can pass the string that I want to find out that. And you can search linearly. So for string comparison, there is a function called strcmp, string compare. So okay, so let me do this. So basically, in strcmp, if suppose you have to consider that you are passing the name here. So name of 0 is Apu, name of 1 is Sam, name of 2 is Gadi. So you just have to run a for loop, and within the for loop, you have to compare the strcmp string compare name of I and the guardian. So if the value string compare value is 0, that then you can say that yes, it exists, and otherwise you have to say that like we have not found. So similar to whatever I have shown here, like this only, but instead of here, uh, we have some like string. So basically, instead of x of I element here, we have to write that if strcmp x of I, instead of like, you can say name of I, and you have whatever the values, let's say maybe 5. So if this is 0, equal to 0, then same logic. So only changes here is this only, and you have to check the data type, like array type. So that's it. So again, array of string works exactly the same way as array of integer, array of float. Only thing is that you cannot just like compare it equal to or greater than equal to like this. There are some conditions which you have to use, which is extra simple. So let me go to the next question, next part, that I want to do sorting on the arrays. So what is sorting on the arrays? Let's say for uh, for like string for names. Suppose we have Atul, Amal, Gargi, Gautam, like these 4 names. What does lexicographical sort means? That let's say uh, in this case, what name will come first? So basically, you have to check element by element. The first element is capital A, and G. So A will come first before the like G. So obviously this two will be the options for first element, right? So this this is a, so this is tie. So for tie breaking, you have to go to the next element. What is the next element? Here it is T and here it is M. Which comes first? M or T? M is before T, right? So M, this one will be uh, coming here. This will be at the second. Similarly for Gargi and Gautam, R comes before U. So this will remain second position only. This will remain at third position only. So by lexicographical comparison, we mean that we have to check element wise, and if uh, if some element is like lesser, some element is greater, then obviously we have the answer. But if it is same, then go to the next element. If that is also the same, go to the next element. No, sorry, like go to the not element, like, go to the next character. This is. So let me just quickly ask a question. So if I make a array like this, So assume that we are doing a bubble shot here. Okay. So what will be the first step? Like let's say assume that uh, we have done one pass. Okay. So what will be the last element after pass one? Assume these four are the elements of the step that I have studied. Our logic is same as showing an array only. So the largest element is find. So if you consider lexicographically, what is the largest element among the two? Okay, let me answer this question. So basically, uh, let me do it like this. So basically, at the first element, if, like the question is that I just want last element, right? So last element is whichever is the largest, right? So we'll start checking from the first element. So in all the cases, it is A. So this is like I or all, right? So in next case, uh, here we have A and we have three M's. So A, B, C, D, E, F, G, H, I, J, K, then L, M, L, M. So K comes before the M, right? So whichever comes later, that is like larger. Okay? So K will come before all these three. So this one is not like this will not obviously happen. So this is out. Let me try. Okay, let me just go ahead and correct. So this is not an option. So now we have three elements. Okay, M again is type. I have I and A at this position. So A comes before I. All right. So again, this is not the largest. This is also one. Now I have Amit and Amiya. So in this case of T here, like we have Y comes after T. All right. So this one is smaller and this one is larger. So this one is also done. So this one will be the largest. So after running one pass through this array of string, the last element will be and yeah, what the first element that's not part of the question. But let's say this is the like this is let's say first pass. Then let me go to the second pass. What will be the answer? Second pass, so second largest element. So what is the greatest among these three? Greatest here is Amit, right? So Akash is there is A here, so there is K here, which is uh, lesser than M. Lesser than means it comes before M in the alphabet. M, MN is similar. Here A comes before I, so this is also not correct, and it is second pass. So okay, so like this. So, okay. So one thing is that these are not necessarily correct. Okay, like these are not in correct order. They're not in correct order because we are not really sorting this in such a way. And the question is that let me just write it in a quick minute. So in this case, this will be like uh, this, and Amol and Akash will be the other. Then if we go to the third bus, in this case, which one is higher? Which one comes later? M comes after Akash, right? M comes after P. So in third bus, it will be like first thing will be Akash, then Amal, then me. then- So this is how you check lexicographical order. So how does the comparison work in C? So here is an example. So let's say you have two strings, okay, S1 and S2, and let's assume that you have S1 is equal to Amol and S2 is equal to like S2 is right. So what will we do? We'll go through each of the element. We are passing an value, okay. I'm saying that unless I am getting end of at least one of the string, I'll continue. Okay. So then here what I'm checking that if S of I is if S of I is greater than S2 of I, S1 of I is greater than S2 of I. So basically what I'm saying is that uh, there are two strings. I'll return one if uh, I'll return one if this one the first value is greater, otherwise I'll return zero. So here what you're doing, we are checking first element. Are they same? Like this. Uh, so the first element is that is the first element greater than the first element in first string is greater than the first element in the second string. If it is greater, then I'll return here one that is first string itself is greater because like we are checking element wise or say index wise. Even if like at each position, if some value is greater, if the character is greater, then and there we can decide that this is the greater string. Okay, but if it is instead not greater, it is like lesser. So maybe here it is like A and here it is like B. So you can return zero. That no, we are signaling that string two is greater. Okay, so here if string one is greater than string two, then we'll return one. Otherwise, we'll return zero. But note one thing, like if this condition satisfied, you have return one. If this condition satisfied, there is return zero. But what is the case when both of them are equal? So even though it is not explicit here, here we have written. So see, if it is greater, not greater than, and if it is not lesser than, there is only another option that they are both equal. So in this case, we are doing I plus plus, and then we are again going to the same. So then it will check the index one, then it will check index two, unless they have found some element, found some index where like the characters are different between the two strings. So this is we call lexicographical arrangement. And one thing is that let's say we have an array like this. I have like let's say I have two elements. Let's say one is Amit and second is Amitabh. So in this case, here you can see there are only four digits are there. Here also the four digits are. So the question is that which one is greater? So the answer is that if if there is like all the elements are matching, then whichever is larger, that is better. So if you arrange them, Amit and Amitabh, so this will come first and this will come later. So and this condition only applies when all the elements in the smaller array, smaller string is exactly the same as the larger string. In this case, this is the larger. Then, okay, so how to define array of string? That is also mentioned here. Like you can define it like this, like spike. And so one thing to note here is that if you are defining with every character, then you have to give the null value and then slash there. Otherwise, like it will not understand that this is the end of the string. But if you are defining with double quotation every character at once, then automatically it will take slash zero at the end. So these are the two things you need to remember. There might be some quick questions as well. Okay, so then printing an array of string, it is very similar to printing. Let me just turn on this program. So here you see like I have defined that I'll have three elements, and within three elements we can have up to 10 characters, right? So it will assign 10 character for this, 10 character for this, 10 character for this. So even if I'm not using 10 characters at all, like see here only 5 characters are there. Need to include slash zero null character, then it is 6. But still it will assign the 10 characters, like 10 memory items for this. So how to press string? You just on the for loop, and here in case of string, just give the address like for string. You write each array. So this is the array, factor array, and plus I. So this is basically similar to like so so, instead of making complicated, let me just this. You can print exactly the same way. Let me just also give the address for some of this. So the syntax is exactly the similar. So instead of using percentage d, you just have to use the percentage s, which is for string. Rest of the other things are exactly the same. This is the syntax. Let me just so first thing is pipe from Jerry lines. Just use the percentage and then index it like to do in the integer. So, and one thing to note here is okay. Let me then let me come to the data representation. So basically, uh, let's say you have two arrays. Okay? Like for example, assume that you have and you are like trying to measure the temperature within a pool. Uh, there are some depth, like maybe at 50-meter deep, you have temperature 20.5. 100-meter deep, you have temperature 19.5 like this. So what are the ways you can store this? So one way will be that obviously you can store it 2D data. Like sorry, like let's go to the obvious first that you can store with one element, mm, one array for the depth, one array for the temperature. Right? But thing is that suppose you want to sort this by temperature, or maybe like just for a moment assume that you have something this here, maybe 100 is here, something is here, 50 is here. So assume that you have this kind of input. So if you want to sort it, then how do you have to do? Like have to also consider that if I like suppose I'm sorting and 50 comes at the first position, but then this temperature becomes wrong, right? Temperature of 50 is 22. So if you are doing some kind of sorting, you also have to make sure that you are also sorting other array accordingly. So suppose I'm bringing the 50 into here, 50 into the first position. I also have to bring the corresponding value 22.5 here and 19.1 here. So this is a like something. Sometimes it can get complicated if you use a large number of array. Another way is that you can just use a 2D array like this. So I'm saying that I'll have 5 elements, and within each element we have two type of values. So we can give 50, 22.5. So 50 is the depth and 22.5 is the temperature. This. So you can continue like this, but the issue here is that we cannot do so. Initially, see here, uh, depth is an integer, but float is in if you define it as a float because temperature itself is float. So you have to use float because if you use int here, you will get only 19. So you have to use float here. But if you use float here, you have to also store this 50 as a floating point. So the range of the value will be less, right? So this is some trading. So then I'll come to the bisection method. So basically, what exactly is bisection? Let me just write graph. So assume that you have a graph like this. And assume that you have a function, maybe something x square plus x square plus 2 is equal to 0. Something like this. I'm just saying something like that. And let's say maybe the graph like the curve looks like this. Okay. So by finding rule, what I mean is that at each point in x, does the equation crosses the x-axis. So basically, suppose this is the equation, this is the curve. You have to find this one. You have to find this. So this is what I call finding. So basically, there are multiple methods of that. So one method is that bisection. Bisection means like you will divide, you will make some initial guess and you will try to like divide the guess with half. So this is very similar to the binary search method. So one thing to note here is that let's say here, let me just remove that. Let me also change the color. So let me say that maybe this is x equal to 1. Like this. Just like this is rough. So one point is that, let's say I am taking a value. So let me consider that I am taking a value that one. One is the one initial guess. Okay. Initial guess is one. So what is the value of y? So here x square plus 2 and same something. So for now, actually forget about the equation. Just focus on the graph. So just focus on the graph and what is the value of a? Let's say, let me also draw something here. Maybe let's say the y is like this. One, it is 0, it is -1, it is 2, so let's assume that we have initial guess that x is equal to 1. And what is the value of y here then? Y is 3, right? Suppose x is equal to 1, then y becomes 3. And let's say x is equal to maybe 5, then y is equal to maybe let's assume that it is. So the thing is that if you see the y value, both of them are positive. All right. So if you try to search some values within x equal to 1 and x equal to 5, there is no guarantee that there will be 0 at some. Basically, what we want the points where y is equal to 0, right? Here y is equal to 0, here also y is equal to 0. Even though you can see this in the graph, yes, if you look the points in between, there is some value which is 0, but that may not be registerable. So, for example, I am checking like this. For 6, the value is maybe y value is maybe 7. So x equal to 6, y is equal to 7. So if you try to find a value, like find something between, so this is also positive, this is also positive, correct? So if you try to find some place where it intersects with the x-axis, this is not possible. So the thing is that if both the values are positive, or if both the values are negative, then there might be some root where there might be some intersection, there might not be. We cannot guarantee. But let's assume that I am taking something other than that. Let me assume that I am taking 3. Okay. So value of 3, if you check, it is like it is the downside, right? And it is like let's assume it is if x is equal to 3, y is equal to -2. So if you now combine this one with maybe just take a minute, maybe let's take 5, this one. So if you say that I will try to find, so now you can guarantee, see, one of them is positive, one of them is at negative side, one of them is at the positive side, and the line is continuous. So obviously there will be some point where that is intersecting with the symbol, with the x-axis. So what is the idea in this case? Similar to the binary search, initially what it will do, we will do one thing. X is equal to 3, y is and x equal to 5. So we have two candidates. Let's say I'm trying to find between them. Okay. So initially I will take x is equal to 4. So y 4, it is midpoint between 3 and 5. So I'm taking this x is equal to 4. Then I'll again draw the line like this. So what is the value here? X is negative, right? So maybe y is, assume I'm saying this is a just a rough sketch. I'm not saying this to for better understanding. This is not the scale. There is no real equation. So assume that I am coming at this point and uh, I'm seeing that here the value is still minus. Okay. So minus means what? We need to go up to find the place where the value is like intersecting with x-axis. So that means I can do one thing that I know. Initially, I thought this value. Let me give some. Initially, I thought the point that we want to search for is within this point. Within this point. So initial guess was that the point is between this point and this point, right? But now I found another number. Now what will be the my guess? My guess will be that this is obviously below. So there is no point searching between this. This is done. There is no zero. We have to search between. So high was initially we assume the high was maybe 5, low was 3. Now here low will become 4, high will remain the same. Then I will do one thing here. I'll take another value, like let's suppose 4.5, 4.5, and we'll draw a line here. So 4.5 is again greater than the value is not here. Value is on the above of the x-axis. So we know that we'll get a positive value here. Like maybe it is like 2.5, something like that, sigma axis. So no, now that we know that this is positive, we know that we have to look below, not above. So we can say that there is no point in searching here. We will search here. So by each step, we will reduce the number of like searching range, and till we get some solution that it is very near to the x-axis, then we'll stop. So this is what we call bisection method. Bisection because we are at every point we are dividing the searching area, searching line, like, because we are taking the middle. So if you go through an example, initially, let's say you have an equation x square minus 2, and initially the value x0 is 1, x1 is 2. So initially the midpoint is 1.5, just the average, and here 0.25 is if you calculate this, like 1.5 square minus 2, you will get plus 0.25. So that means it is too big, like it is on upper side compared to the x-axis. So that means you have to consider that lower side will remain the same, but upper side and saying that one like the value will be between 1 and 1.5. Similarly, I am checking the negative value 1.25, and then I'm saying that it is going to the negative. So that means the value will be between 1.25 and 1.5. Like this, it will continue, and ultimately after some point, you can see that there is very little change. So that point, you can stop and say that this is the root of the equation. So basically, what I'm saying is that if I give 1.41 to 1 to the value of x, I'll get 0. So that is what we can say. So that is what exactly is represented here. That at each point, the value of y is 0. At what value of x, the value of the y is 0. So here you can see that there are two values. Like 1 point here, 1 point here. So there can be multiple solutions. So then this is implementation is with that. Uh, then there is another method called Newton adaptation. So this is little bit different from the bisection method. In bisection method, it is quite actually slower compared to the introduction method. So basically, what does it do is that let me just show it out. So I assume that this is the so I assume that you have a like a bold black line that is actually the equation. Okay? And this is like f of x, which is like y. And initially, assume that you have made a base x x1, okay, and you got a point. You got the value of y here. Then what to do is that you have to take a prime x. So basically, a prime x is that like let's say the equation is like x square minus 2. So what is f prime x? It is like 2x. So basically, you have to take a derivation. Then there is okay. So basically, the update equation is that this is the update equation. So initially, assume that you are taking an initial guess here, okay, and you saw that this is much higher compared to the initial guess. Sorry, compared to like the zero value, okay, compared to the root. So what you have to do, you have to find at first you have to find the x, like you have to find the y, which you can find by the equation. Like let's say if you have x square minus 2 and here uh, plus x square minus 1 and here assuming that we have x equal to 5. So 5 into 5 is 25 minus 1 is 24. So if of x is 24 divided by if prime x. So if prime x is 5, suppose you have this, f of x is assuming x squared. Sorry. So suppose x equal to 5, then f of x is equal to 24, right? And f prime x is f prime x, if you take derivation of fx, so it is like 2x, right? So f prime of 5 is so 24 by 10 is 2.4. So you have to take a step like this. The new step will be like this. So initially assume that we have 5 here and the new step will be 5 minus this one. 5 minus 24 by 10. So it is like 5 minus 2.4, which is 2 by 6. Got it? So the advantage of this method is that it is quite fast. Like let's say assume that you have equation like this, x square minus 4, and even if you start at x is equal to 6, so this is see the root of x square minus 4 is 2, but even if you take a deliberately wrong this at a very like large number like a 6, or even if you take larger number, it will like converge very fast and it will give you the root because the rate of change is quite high. You don't need to go for the midpoint of it. But there are some disadvantages of this method as well. So what is that? Like, let's say assume that something like this. So what did I say? Like in this case, in case of bisection, if you see a point like this, like if you see a point like this and point like this, you can guarantee that there will be a zero, right? Uh, Even if you say the curve is like this, it is not necessary that it will be like single, right? It will be like this, this also, right? So even in this case, see uh, here, if you check, where if you check, both are positive. So in this case, there is no guarantee. So if you find some values where one is negative, one is positive, you can guarantee that there will be zero in bisection. But in case of like in case of neutron action method, what is the issue? Assume that your initial guess was this. Okay. Your initial guess was this, and you thought it is coming down like this. So maybe you guessed some value like this, some other value like this, some other value like this, from this like this. So it is possible that you will get stuck in here also. Here only, you may not go to the this one or this one. So this is the issue with neutron eruption method. So these are the basic differences. Now, when to use which method? So one thing is that you should use bisection method when you uh, need the location of the root, but if the equation might be complicated, you don't have it is very difficult to compute the derivative. Okay, and also you want it to be very reliable. So like reliable in the sense you can guarantee that this is the correct one. Okay, so that is what is called about reliability. And then also when to use interaction method, that you need very quick result and derivation is available, and you can create give a good estimate. Because if the estimate is see here in this case, if my estimate is like this, okay, if my estimate is like this, I can come down here. Here I'll find that this one ultimately. But if my estimate is here, then I may get stuck. So if I can figure out some good estimate from intuition from my domain knowledge, then that is a good idea. But otherwise, we should prefer bisection. Another thing is that we can do one thing for figuring out the actual range, we can use bisection method. Maybe let's assume that we don't have any domain knowledge, so you can do one thing. We can use bisection method to find out this range. And after finding the range, to quickly get the actual root, we can use Newton action. So let me go to the questions now. So this is the first question. A bisection method is used to find derivative of a function at a given point. Numerical integration of a function within a range and the root of a function. Option D is non-empirical. So which option is correct? Okay, so the correct option is C. You are right. Root of a function. So obviously, it is root of the function here means at which point in x it is it is the curve is intersecting with the x axis. So the second question is that what is the worst case time complexity of linear search? Order of n, order of log n, order of n, order of 1, log n, and n squared. Uh, Note that this is worst case, not best case. Yes, the correct option is actually C. Um, So basically, in linear search, what happens is that if you don't find the in the worst case, you have to search through all the elements in the array, and at the end, you may find the element, or like even if you don't find the element, you have to search through all the elements. Then only you can basically say this in one data. So, for this, C is the correct option. Okay, and then question 3: in which search we start at the beginning and check every element in the list. So this is very easy. Yes, so the answer here is linear search. Here we have to search all the elements because it is uncertain. So like, there is no intuition will work here, right? This will be in the right side, this will be in the left side. What is the worst case complexity of bubble sort? Answer is not B. It is not log. Okay, so basically in bubble sort, if you see that there is outer loop, there is another no. And we are not dividing the array by some part like, like binary search, if you see, we are dividing the array by pattern district. So that kind of thing is not short. So outer loop will run n times, inner loop will also run n times. So n into n is n square. So the correct option is B. Okay, so what is the main disadvantage of the bisection method? So actually the answer here is that it cannot find complex. So basically suppose if the root is complex number, it is like it is not computationally like it, yeah, it is expensive than the other option, but it is not really very much expensive. And it is not really your requirement here. Okay, just as I mentioned before, like even if it is like not differentiable, for neutral adaptation, it needs to be differentiable, but for bisection, that is not a strict requirement. And it is not guaranteed to converge is also not because if you find that value, one is positive, one is negative, there is guarantee for convergence. So the answer here is B. Then this is a question of a pointer. So I am giving, I have a variable in pointer and pointer one. I am giving the address of array to the pointer, and then I'm performing some operation. So then I'm printing pointer to minus pointer one. So what will be the value? Okay, I just received an answer 30. Any other answer? So yeah, 30 is the correct answer. So basically what is happening here is that here in the pointer one, the address of the first element, so in this one is here. In pointer two, I am saying that pointer one plus three. So note here, there is no star. If it is star, then it will consider value. But here there is no star. Here I am saying that pointer one, so this plus three. So next three elements. So this is like 0, 1, 2, so 4. So I'm saying in pointer two, assign 4. Okay. So here in pointer two, so not really 40 actually. So here I'm saying that in pointer three, assign the address of the 40. Okay. So when I am completing, so it will consider like the address of this one minus address of this one, and star means corresponding value. So 40 minus 10 is 30. Okay, so this is assume that actually you have assume that you are starting with x is equal to 1 and x is equal to 2. Can you just calculate the first step with bisection method? So bisection means you will take 1, like the value will be 1.5, right? Then if you calculate this equation, you will get a number, like you will get an f of x. Then after that, what will be the mid, what will be like what will be the low, and what will be the high. So initially, this is the low and this is high. So after first step, what will be the low and what will be the high. So basically, you just have to replace x with 0.5. See if that is positive or negative. So basically, in this case, I have just shown all the steps, but basically, what is happening is that at the beginning, let's say A is your low and B is high. So 1 and 0 and starting with 1 and 1 and 2. At the if we try to find a midpoint, it is like constant value, right? And if you consider this equation, like this. So if you see this equation, if you put say x is equal to 1.5, what will happen? You'll get 18.37. So this one is greater than 0, right? So in this case, we need to find a value between 1 and 1.0 because 1.5 is already 18. If you go above that, 1.6, 1.7, you can know. We don't want that. We want f of c to be 0. Okay. So this is the first iteration. The second iteration, it is like 1.5, 1 and 1.5, it is 1.25. So again, this is positive. So 1.25 will come to the high. Similarly here, 1 and 1.25. So midpoint is 1.125. Again, this is positive. So 1.125 will come the high. Here, in this case, it is like 1 and 1.125. So midpoint will be 1.0625. Again, this is positive. So it will go to this here. And again, if we find midpoint, then it is like it is negative. So if it is negative, in the next step, it will be like a point, this one. Uh, this one will come to the A, and B will remain the same. So if it is positive, A will change. If it is negative, A will change. Like this. But since we wanted only 4 steps, so 4 steps are done. Uh, like so, we can give an answer 1.029. Then what is the output of the following program? So basically, you have a program like this. You have a pointer, you have an integer variable, you have some like you are assigning the address of A to the pointer, then you are doing some substitution operation. So okay, will it go to some random element in the memory, or the value of the A will change? Okay, I'll come back to this question in the previous question. So the answer here is actually 2, 2, because see here uh, we are assigning the address of A to pointer, all right, and then I'm saying that whatever value is there in the pointer, decrease the value by 3. So basically, it is saying like whatever address is there in pointer. So what address is there in the pointer? Address of A only it is. So it is changing this thing in the location of A. So if you write star pointer, so pointer contains the address of A. So and the address of A now contains A because we have already decreased. Similarly, if you just write A, it will also give the address of A. So that is also the same thing. Let me go to the previous question once. So basically, here I am saying that initially you have like let's say you have some random guess initially that maybe I will find the value between 1 and 2. And you already know that if you take f of 1, then the value will be negative. If you take f of 2, then the value will be positive, right? So in bisection method, how do you do is that this is low and this is high. You take the average of this, so 1.5. Okay? You then use this function, whatever function you are trying to find the root of. You use this function, you replace all the x with infinity. Then if you calculate the equation, you'll get a value 18.37. Okay. So that means you try to find out a value. You try to find out the y, which is positive. But what do we want? We want y to be 0. So if we want y to be 0, the we have to search between 1 and 1.5, because if we go from like 1.5 to 2, it will be like 19, 20, even more. We don't want that. So we are deciding, since this value is positive and we want 0, and we already know that if 1 is negative and 1.5 is positive, so next time we will search between 1 and 1.5. So next step, 1 and 1.5 is there, average is 1.25. Again, apply the instead of x, use 1.25. I am getting a value. So again, it is positive. So I can say that I know if we use 1, this will be negative, and 1.25, it is like positive. So you can just search within these two value. There is no need of searching between 1.25 and 1.2 because that will be positive number. Like even there will be no zero within that. Same thing we'll repeat again and again. Like if it is negative, then we'll consider that see one thing here it is positive. So next to search between like 1 and like midpoint. Okay? Here also it is positive. So we'll search between the starting point and the midpoint. But here it is negative. So in the next step, what it will do, we'll search between the midpoint and the end. So because this is negative, I can say that this will the searching value that we want, it will be between this and this, not this. So ultimately, after running for multiple iterations, you can see that it is this value f of c. This is getting very close to zero, and in that case, you can stop that. Yes, we have found the root. We have found the value of x where it is very where it is intersecting with the x-axis. So that's the answer. Okay, next question. So you have an array, you have some pointer and some value. So what will be the order of the int here? Okay, so pointer doesn't really contain address of A in the sense. So if I say a pointer is equal to A, so in that case it will be like address of A. But since I'm saying A plus 4, so it will be like 0, 1, 2, 3, 4. So pointer contains address of okay. So the answer here is that like I have said, P is equal to A plus 4. So A means address of this, but since plus 4, it contains address of 2. Okay. So if you run it like this, I equal to 0, I listen to I plus plus. So initially P of minus I. Minus I here is at I1. I is like 0. Okay. So my pointer here is at this point. So it will print next iteration I is equal to 1. So P of minus 1. So minus 1 is what? So basically, note here, on thing note here is the pointer is content here. So if you do the plus one, if you go to the next step, it is a minus one, you go to the left. So like this. So initially it is 0, it is just like here. Then it is minus 1 here, minus 2 here. So output will be from the backgrounds 2, 7, 6, 12, 10. Okay, so this is the final question. You have some data 74182. If you do the bubble sort, what will be the ordering? Like what is the sequence of order? And I'm not saying that entire step. I'm saying like consider that maybe 7 and 4 injection that is one step. Maybe like 1 and 7 injection that is another step like this. In the previous question, if it is like P of 0, so I'll come to the next question. So since you see that here, we have assigned P as this one, right? I have not assigned P into A. I have assigned P is like A plus B. So P is here. So if you give P of 0, that will be here. This one. So P of 0 or P of negative 0, this is. Okay, so if you just consider like this, in bubble shot, what happens? Like you just compare this with this like this. So initially, what will happen? 4 comma 7, because 7 is here, 4 is here, you will get the distance 4 comma 7. So all this case and rest of the three elements will remain the same. So 4, 7, and 8, 2, that is fine. Okay. All of them are correct. Then next step, what will happen? 7 and 1, it will get exchanged. So what will happen? 4, 1, 7, 8. 4, 1, 7, 8, 2, 4, 4, 1, 7, 2, 8. So this is wrong. This is obviously wrong. So only a B is correct. Okay. So if you go step by step, like 401, 417, 8. So here only these two positions will get action, 4, 7, rest of the three will remain same. Here 1 and 4 will get exchange. So 4, 1, 7. These two will remain same. So this one is the only correct option. So if you have any question, please feel free to ask. No, A is not the right option. Okay, if you don't have any questions, I will end the session. Thank you for